Welcome back for the video for lesson 4.4. And this video and lesson is all regarding the counting rule and the fundamental counting rule, which is going to look similar to the multiplication principle. We're going to learn about factorial notation, and we need to use that or know how to use factorial notation and what it is to be able to calculate permutations and combinations. Now, we're not going to dive heavy into permutations and combinations. We just need to understand what they are because we're going to have a shortcut to the process later on in some other chapters. So the fundamental counting rule is in a sequence of n events in which the first one has k1 possibilities and the second event has k2 and the third has k3 and so forth, the total number of possibilities of the sequence will be k1 times k2 times k3 all the way through kn. This means we're multiplying each of these possibilities. So let's look at example 1. It says, recall from earlier in chapter 4, we looked at finding the sample space of all possible outcomes for the gender of a family having 3 children. How many outcomes are in the sample space? Well, for child number 1, there are 2 genders. For child number 2, there are also 2 genders. And for child number 3, there are also 2 genders, which gives us 8 in our sample space. Let's look at another example. How many possibilities are there for a 5-course meal if there are 2 soups to choose, 3 salad, 4 vegetables, 5 main courses, and 6 desserts? So for the soup, there are 2 times 3 salads times 4 vegetables times 5 main courses times 6 desserts. So we're going to go to Desmos and multiply those. And that tells us that there are 720 different menus to choose. Let's go to example 2. Example 2 says, I have 8 students in my class and I pick one to read the opening lesson introduction each period. How big is my sample space for Monday through Friday if a student can be chosen more than once? So Monday through Friday means I've got 5 days. Monday, Tuesday, Wednesday, Thursday, and Friday. And it says I can choose a student more than once. So that means I've got 8 students for each day because each student could be chosen more than once. So I can also write this as 8 to the 5th. And that, I'll show you how in Desmos. Here in this is going to be 8, and your shift key and your 6 key will go up into an exponent. You can also do 8, and then if you click this menu down here and open up the menu, you can click this A to the B button right here where my mouse is, and it will also go into the exponent. So there's 32,768 ways I could pick those 8 students to read the introduction. Now, part B says, how big is my sample space for Monday through Friday if a student cannot be chosen more than once? Well, that changes things a little bit. So that means I have, for Monday, I have 8 choices. But for Tuesday, the student I chose for Monday cannot be chosen again. So that means now there's only 7 choices. Then for Wednesday, there's only 6 choices. Thursday, there's only 5 choices. And Friday, there's only 4 choices. So I'm going to multiply those in Desmos. And it says I've got 6,720 in my sample space. Okay. Sample three. A movie theater plans to show 7 different movies, one per night over 7 days. Each movie can only be shown one time. How many different ways could the manager select the order of the films the theater will show? So, you've got 7 for the first night. And 6 for the second night. 5 for the third night. 4 for the fourth night. 3 for the fifth night. Then 2, then 1. And that equals 5,040 ways that you could show those theaters, those movies. And this, what we just did, is called a factorial. A factorial is shown with the number and an exclamation mark. And it means that you're taking that number and multiplying by subtracting 1 and multiplying that by subtracting 1 all the way down through 1. So on the next page is the official definition of a factorial. Let's compute some more. So 5 factorial is 5 times 4 times 3 times 2 times 1. And that is 20 times 6, or 120. 0 factorial means we just have 1. And then 7 factorial is what we just did. 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040. Okay, so sometimes you're going to say that you've got items that you can choose, but you don't want to choose all of them. And you want to choose them in a particular order. So a permutation is the arrangement of n objects in a specific order, so order matters, using r objects at a time is called a permutation of n objects, taking r at a time. So for instance, if I had 5 books, if we had 5 books and you want to pick 3 at a time, and the order matters. So order matters with permutations. So it's n permutating r is how it's read. And this calculation is n factorial over n minus r factorial. But the great thing is we can use this in there is a command, and I'll show you in a minute. So let's write one out. 10 permutating 9 is 10 factorial over 10 minus 9 factorial, which is 10 factorial over 10 minus 9 is 1 factorial. And so 1 factorial is just 1, so it's really just 10 factorial over 1, which is 10 factorial. And so I'm going to show you in Desmos. Okay, so 10, and then you can just put your exclamation mark, and it will give you 3,628,800. Now, you can also do 10 permutating 9. So you go into your menu and over here to the right under functions. And then all the way down, there's some statistical functions that we've been using. But also, if you go all the way down to the number theory, we're going to choose NPR. And so then we're going to put in that parentheses n, comma 9, because we're n permutating 9. And we get the same answer as above. So let's look at B. B is 7 permutating 5. So I can copy that permutating, control copy and paste it, control V, and change that to the next one, which is 7 permutating 5. So B is 2,520. And then I can paste it again and change it to be 4 permutating 4. And there's 24 ways you can do that. Let's go back to our paper here. Here are the permutations that we just did in Desmos. Now, if you wanted to choose those 3 books from the 5 books, and you didn't really care about the order, you just wanted to grab the red, the blue, and the green book, and you don't care which order you grab them in, and that's called the combination. There's less choices. So the number of permutations of n objects when R1 objects are identical, R2 objects are identical, and P objects are identical is n factorial divided by R1, R2, R3, where R1 plus R2 plus R3 plus P equals n. Combinations are the number of combinations of R objects selected from n objects is denoted by NCR, and it's given by this formula. And this is where order does not matter. So let's practice putting these in to Desmos. There's a command for those as well. So I'm going to share my screen. And I'm going to go down and I'm going to go over to the menu and over to functions and down to number theory and choose the very last one that says NCR, and I'm choosing 9,6. And so there's 84 ways of 9 choosing 6. And you can see when it was NPR of 9 choosing 6, there were 60,480 ways. So when you're doing combinations, you're getting much fewer choices. Okay, I'm going to copy that NCR and paste it here for another one. Let's do letter B, which is just practicing the 7, choosing 4 is 35. I'm going to paste that again. And I've got 5 choosing 1. And that's just 5. So let's look at a couple word examples. Example 7 says, the Foreign Language Club is showing a 4-movie marathon of subtitled movies. How many ways can you choose 4 from the how many ways can they choose 4 from the available? So in this one, they're choosing 4 from the 11 available. Sorry about that, from the 11 available. So there's 11 to choose, and we're choosing 4. So we're going to go to Desmos and paste, and I'm going to do 11, choosing 4, because order does not matter. So there's 330 ways they can choose those 4 movies. Let's look at example 8. The Foreign Language Club is showing a 4-movie marathon of subtitled movies. What if they cared which order the movies were shown in? Then how many movies can they choose from the 11 available? So because order matters, you care about the order, we're going to do 11 permutating 4. So there's going to be more choices. On this one, I'm going to go up and I'm going to copy my permutating. And we're going to do 11 permutating 4. And now there's 7,920 choices. So many more choices. Okay, the last example is 4.4, Chapter 4. An online coupon service has 13 offers for free samples. How many different requests are possible if a customer must request exactly 3 free samples? So order doesn't matter. I'm just going to write that order does not matter. And so we're going to have 13 choosing 3. And so I'm going to go to Desmos and I'm going to copy an NCR, or you can just go to the menu and go down to functions and down to the number theory. So 13 choosing 3. Looks like there's 286 ways I can choose those free samples. So catch me back for another video.